This is ASPure Maths notes. We're in Unit 9 logarithms, and we're now on to then 9.5, which is graph transformations of exponential functions. So if you have y equals a to the power of x, and you're plotting that graph, what's it going to look like? A wee example would be, so we'll kind of take this over to the side, is y equals 2 to the power of x. If I put 0 in here, 2 to the power of 0, that just gives me 1. So whenever x is 0, it's going to be 1. If I put 1 in here, it's going to be 2. If I put 2 in here, it's going to be 4. And 3 is going to be 8. And 4 is going to be 16, and so on. So this gets kind of big fairly quickly. That's an exponential graph for you. Over on this side, minus 1, 2 to the power of minus 1, that gives me a half. And then it goes to a quarter, and then it goes to an eighth, and so on. So generally, our graphs look like this. It's nearly better having my hand the other way around for that. That's a dodgy looking graph, but we're kind of there. And that then is our point 1, and that's a fairly standard one then for y equals a to the power of x. What about this one then? Hence gets the following. So y equals 3 to the power of x. Again, if you put 0 in there, it's still 1, but it just gets steeper more quickly, I suppose, you know. So we would have that. That's not supposed to be a straight line there. It's supposed to curve around from there. But we have that. If you wanted, for example, 1 point, that would be the point 1. And then that would be the point 3. Y equals 3 to the minus x. Again, let's have a wee think here. If I sub in 1, it's actually minus 1. So 3 to the power minus 1, then that's going to give me a third. And then I put in 2. 3 to the minus 2 is a ninth. So it's actually this graph here, but kind of turned around going the other way. And so my curve then should look a bit like this. That gets closer and closer and closer, but never touches. And we have that, and again, that's still my point 1. I should have that one and the one above as well. So it gives us then something like that. Y equals 3 to the power of x minus 1. So things are going to move across here. So say I put 0 in, then it's going to be minus 1. So that's going to cross this time as a third. And then whenever you put in 1, it's going to be 0. So then it's going to be 1. So the point 1, 1 is going to be in the line. And then whenever you put in 2, it's going to be 3. So hopefully this is making a little bit of sense. You just sub numbers in. So the point then 2, 3 should be on. So again, if I try and draw my curve like that, hopefully you remember your graph transformations and the fact that it's an x minus 1. What we've actually done is move the graph 1 across that. So we've taken the graph of 3 to the power of x and we've moved it effectively like that. That is one of our graph transformations, if you remember that. Finally then, our example 4, y to the 3x plus 1. So anytime we do 3 to x, if you remember that, again went through the point 1, we're just adding 1 to any of these. So same graph, same shape, just all a bit higher. We have that, and that then is our point 2. We actually still end up then with a wee asymptote here, so instead of it being at 0, that asymptote happens then at 1. And that's us, I think, then for our graph transformations.